Chapter 3 test, you guys had an option of picking two proofs. So if you had the first test, number 17 said given AB is perpendicular to BC, and if I tell you that angle 1 and angle 2 add up to be 180 degrees, prove to me that this line BC is going to be perpendicular to CD. So, and I told you there's about 3 to 4 steps. So if we start off with our proof, we start off with the given. So we already know AB is perpendicular to BC. I'm sorry. And we know that measure of angle 1 plus measure of angle 2 equals 180 degrees. That's all our first step. For some reason, the Smart Slate doesn't want to write vertical angles or vertical lines today, or horizontal lines. Okay, so we know that that's what that right angle means, and we know these angles add up to be 180 degrees. Now, if these angles, angle 1 and angle 2, add up to be 180 degrees, if you notice, these are same side interior angles. So this one and this one are same side. So that means that this line and this line have to be parallel. So our second step is going to be like, okay, so AB has to be parallel to CD. This is a given, sorry. And that's because they were same side interior angles. But because we're proving lines are parallel, we're going to have to use the converse of same side interior angles. And you got a whole point if you told me the converse of same side interior angles. You have to prove that the lines are parallel. The reason why you had to prove lines are parallel in this one is because then we're going to say, okay, well, if these lines are parallel to each other, and I know one of those parallel lines is perpendicular to this transversal, then this other line has got to be perpendicular to the transversal as well. And that was called the perpendicular transversal theorem. And the perpendicular transversal theorem is really specific. It says, and we talked about this in class and we wrote a paragraph about it. Remember, perpendicular transversal theorem says if we have parallel lines and we know one of those parallel lines is perpendicular to the transversal, then we know that that other line has also got to be perpendicular to the transversal as well. So we can conclude that this line is perpendicular. So that's why it was really important, and you got a whole point if you told me that this line was parallel by the converse of same side interior angles. It would have been impossible to prove it without converse of same side interior angles. Okay, so that was the first one. The second one, everybody had the choice for this second proof. It says prove that the same side interior angles exist. So when I say prove it, it's like imagine that you were a geometry god or something and you didn't know about same side interior angles. You knew about everything else, but you didn't know about same side interior angles or that they even existed. So you cannot use it in your proof because it doesn't exist yet. So if I tell you only that line R is parallel to line S, I want you to prove to me that angle 1 plus angle 2, these same side interior angles, will add up to be 180 degrees. And I saw a lot of different attempts at this one. Some were really interesting. Some were really close. Okay, we're going to start off, and I told you it was about 6 steps. So we're going to start off with our given, and we're going to say, okay, all we know is that those two lines are parallel. Well, if you look at the angles, I know eventually I want to talk about angle 1 and angle 2. So, okay, I can't use same side interior angles, so I'm going to introduce angle 1 into my story. And I'm going to introduce it with angle 3. And I know that they've got to be congruent to each other. And that's because we have parallel lines and we have corresponding angles. Remember, the corresponding angles was actually a postulate instead of a theorem. And the reason why it was a postulate is it's because it's like the mommy, or it's where all the same side interior angles and alternate interior angles and alternate exterior angles came from. So you can think of this as like the mom of all the other ones that we've learned. That's why it's a postulate and not a theorem. It's something we believe to be true. We just accept it to be true. So, okay, I have angle 1 is congruent to angle 3 because they're corresponding angles and we have parallel lines, so they're congruent. Now, if you notice, here's a congruency sign and here's an equal sign in our proof. So one step you could do then is change that congruency sign to an equal sign. And that's called definition of congruency. And some people were super close, but they forgot this step, so they missed part of the point. And again, it's important that you change it from a congruency sign to an equal sign. Okay, and then we have an equal sign, and somehow we have to introduce that 180 degrees into our story. So if we look at angle 2 and angle 3, we can say, well, angle 2 and angle 3, those are a linear pair. So since they're a linear pair, that means that they are supplementary. And I didn't take off points, but you did get an extra points. Somebody in 5th period got this extra point too, if you said that they're supplementary, because the linear pair theorem says that they're supplementary. It doesn't say that they add up to be 180 degrees. The definition of supplementary, that word, remember that word supplementary does mean that the two angles add up to be 180 degrees. So first use linear pair theorem, then use definition of supplementary, and the definition of supplementary is where that 180 degrees comes from. Now, if we look at our story so far, if you were explaining this to someone, you've hit some good points. You said, okay, measure of angle 1 equals measure of angle 3, and you say measure of angle 2 plus measure of angle 3 equals 180 degrees. If you notice, these two characters are exactly the same. So what are you going to do? You're going to kill them off, and you're going to replace measure of angle 1 over here. So measure of angle 2 plus measure of angle 1 equals 180 degrees, and that's what we wanted to prove. So we can say that the last step was substitution. So this is how the geometry gods used corresponding angles postulate to then prove same side interior angles, which is what we can use in future proofs. Okay, the last proof on your test was, another option was number 37. Number 37 said, given angle 1 is congruent to angle 2, and that line P is perpendicular or meets at a right angle to line Q, prove that line P is perpendicular to line R. Okay, so we're going to start off with a given, and there's about 4 steps in this one. Okay, so let's see, we're going to start off with our given again, and a lot of people got this one correct, and I was impressed. Okay, so we have angle 1 is congruent to angle 2, and we have P is perpendicular to line Q. And these ones should have been lowercase, to my bad. This is line P and line Q, it's given. Okay. Well, if we know angle 1 and angle 2 are congruent to each other, they're corresponding angles. Since they're congruent to each other, that means that the line R and Q have to be parallel to each other. And that's going to be converse of corresponding angles. So again, we're using converse to prove lines are parallel. So now we have parallel lines. And then the last thing to prove that P and R are congruent to each other is we can use the perpendicular transversal theorem. This is a lot like that first proof, which is why I put it on both of the tests. Again, perpendicular transversal theorem is very specific. It says if you have two parallel lines and one of those parallel lines is perpendicular to the transversal, then we know that that other line must also be perpendicular to the transversal. So that's why first is really important that you use the converse of corresponding angles to prove that the lines are parallel. So you could have done this, and I smushified the given, and that's why I did it in 3 steps instead of 4 steps. So those are the proofs on Chapter 2 test, Chapter 3 test. And if you are expecting to retake the test, or if you want to study for the semester final or the quarterfinal, these are good proofs to look at. Thank you.